data derived from our part 1. Next is we will produce our statistical report. To do that, make sure to in place properly the data needed for our statistical report. Then you're going to click here on the menu, the analyze. Then select on the sub-menu scale. Then click the reliability analysis. Next thing that you're going to do is to select the items from the right from the left side going to your right side. Like for instance, for this mode number 5 is here. Then we should be included this mode number 5 here on our items found here on the right side. Okay, next thing that you have to make sure is the model. There are different choices here, but I want you to select the alpha model. Then next step, click the statistics. Then as you can see item and scale. If the item deleted will be included as part of the descriptives for this statistical analysis. I want you to check this one. If it's not checked, you just check these two items, item and the scale if item deleted. Then make sure also to check the correlation because we need this for us to identify if there are items that are not helping to measure the same construct. So we can see those correlation by projecting this inter-item correlation. The next step is click the continue. Then after that, you're reporting back again to your reliability analysis window. Then for that, you just confirm if everything was set, then click the OK command button. Then, as expected, statistical report using Cronbach alpha is being produced. What is really interest in us as the researcher is the value of Cronbach alpha here under the reliability statistics report or a table. So you'd see over here the value is 0.402, which is considered to be as non-correlated Cronbach alpha result. In a normal case, if it's above zero point 0.7, because we should expect that we should have at least zero point 0.7 up as the value of our Cronbach alpha. If it's less than this, so meaning just like this one, it's not correlated, meaning it's not acceptable. The acceptable value would be zero point 0.7, and it's considered to be as an adequate value. And above zero point 0.8 is considered as the optimum value. And those are the things that we wanted to establish in our report. Okay, by looking into also here in terms of our inter-item correlation. Okay, inter-item correlation. So on this table, you will see over here that there are the positive value, negative values here, Now the correlation of each item to another item. You will see over here, item number 5 is has has a negative value. So meaning this value is not correlated with the other item. It's not correlated with the responses from item number 1. Same also here. So in most of the value here of our item number 5 are negative. Although there are those also like positive value, but majority is negative value. You will see over here now between 5 and the item number 1, that's negative. Mode number 5, mode number 2, negative also. For this, that's a positive, negative value. So item number 5. So has a big problem here because in most of the value, now based from the correlation in every item, the item number 5 is not correlated. We can see over also here in our item total statistics. If you're going to look at it on the value of Cronbach alpha, if the item is deleted, we can also prove here that there is a problem in item number 5. If you look at it here on item number 1 and 2, which is 0.360, and second item would be 0.185. If we're going to remove this, it will create another problem. It will add up the problem. Same also with the item number 3 and number 4. But if we're going to look at it, item number 5, if we're going to remove this instead of other items, we can have increase our Cronbach value by about 0.824 if we're going to remove this one. What does it mean by that? So meaning item number 1, number 2, 3, and 4 are all correlated. But for this, if we're going to remove this item, I mean, is it does not correlate with the responses from every item that we capture. So meaning if we're going to delete number 5 items, so somehow we can improve the value of our Cronbach alpha. Question is how? How are we going to do that? And why do we need to remove those item number 5? Okay. Going back here to our menu, I want you to use your mouse to improve or to remove item number 5. Go click the analyze, click the scale, then followed by reliability analysis. And you will be ported back again to our reliability analysis. And here, our intent is we wanted to move or remove item number 5 because this is the suspected item that is not correlated with the other items so as to improve our Cronbach alpha value. To do that, you click this one and click the arrow back. Then notice here we only have 1, 2, 3, 4 items. Item number 5 is removed for analysis. So we'll be using only 1, 2, 3, and 4 because we suspected that item number 5 is not a good question. There's no reliability in terms of responses coming from our respondents. That's why we remove that one so as to improve our reliability testing. Normally, what we did, class, now is we just prove right now that if we're going to remove this, it will improve our Cronbach alpha value. But we can also go back to our item here based on our questionnaire, and you can you can modify the question maybe of your item because maybe some does not understand s- uh, does not understand the correct instruction of that particular item. That's why there is a need for us to improve again that item. For now, just want to remove this one so as to prove that number 5 here is an item that has a big problem when it comes to our reliability. Then after that, same process, alpha, then go to your statistics, item, and scale if item deleted and correlation should be included. Then click continue. Then after that, click the OK button. Then you're porting back again to our reliability result. Then if you have noticed here in our Cronbach alpha, after we remove item number 5 from our for having analyzed, then we improve drastically for about like 8 or point 824. So what does mean by that? So meaning your Cronbach alpha is acceptable. In fact, that's what that's the optimum value that we can have. Or if we can have it closer than one, it would be more reliable and acceptable on that particular case. Then that's it for now. So I want you to continue working with your validity and reliability testing of your instrument. Thank you and bye for now.